In this problem, we are asked to use the central limit theorem and the cumulative normal distribution table to find the probability. We're given a sample size and a population proportion, and we're asked to find the probability that the sample proportion falls between 0.12 and 0.16. So if you go back and review the central limit theorem for proportions, that theorem, and this was in section 9.4, right, where this, 7.4, where this problem comes from. So I would just say go back and review the notes on the central limit theorem. The central limit theorem states that we can treat the sample proportion as a random variable. That random variable follows a specific distribution. The mean of that distribution, which we call mu sub p hat, is equal to the population proportion, which is equal to 0.10. The standard deviation of the sampling distribution is equal to the square root of p times 1 minus p over n, which in this case is equal to the square root of 0.10 times 1 minus 0.10 over 200. And if you work that out on your calculator, you'd get about 0.0212. Okay. Now, furthermore, the central limit theorem states that if the sample size is large enough, the distribution that this random variable follows is a normal distribution. The conditions that have to be met in order for it to be a normal distribution is that we have to calculate the value n times p, and this is equal to 200 times 0.10, and that is equal to 20. And we also have to calculate n times 1 minus p, which is equal to 200 times 1 minus 0.1, and that equals 180. Now, as long as both of these numbers are at least 10 or higher, then that means the sample size is large enough that we can treat this distribution as a normal distribution. And those conditions are met. So now I can come down here and I can say, okay, I'm dealing with a normal distribution. So let's go ahead and I don't know why my pen's not working. Shoot. Let's try it over here. Okay. Dealing with a normal distribution. Something like this. I'm obviously not perfect, but you get the idea, right? And because the mean of my distribution is equal to the population proportion, that means this distribution is centered over, let me scroll down a little bit here, the value 0.10. And based off of the fact that I want to find this probability, right? I want to find the probability that the sample proportion falls between 0.12 and 0.16. And remember that a probability is can also be interpreted as the area under a curve, and this distribution is the sampling distribution, so it represents the distribution of all the possible sample proportions based off of samples of size 200. Based off of that, I'm trying to find the area under this curve that falls between 0.12 and 0.16, right? Shade that area here. So in order to use the table, I have to convert both 0.16 and 0.12 into z-scores. Okay? The formula for doing that, you take the random variable minus the mean and divide by the standard deviation, right? So in this case, the random variable would be the sample proportion. The mean would be the population proportion. Standard deviation is given by this formula right here. That is the square root of p times 1 minus p over Okay, that equals. Let me just back up a little bit. Okay. All right. Now, so now let's go ahead and calculate the z-score for both 0.16 and 0.12. I will start with 0.12. Okay, so I'll just say z, and I'll put a subscript of 0.12 just to indicate that this is the z-score for 0.12. Right? So then the sample proportion is 0.12. P is 0.10. Standard deviation is given. I calculated that separately up here, right? 0.0212, and that equals 0.94. Okay. Now let's do the exact same thing for 0.16. The z-score for 0.16, that is equal to 0.16 minus 0.10 divided by the standard deviation, which is 0.0212, and that equals 2.83. Z-score should be rounded to 2 decimal places, because if we're using the table, the table assumes a rounding to 2 decimal places. So now that we've converted both of these values into z-scores, now I can treat this as the standard normal curve, right? So the standard normal curve is the normal curve that has a mean of 0, a standard deviation of 1. It's basically the distribution of all the z-scores. So I'm trying to find the area under the standard normal curve that falls between 0.94 and 2.83. And so if I want to do that using the chart, what I would do is I would flip over to the chart. And I'll come over there right now. And I'm going to, start by finding the area to the left of 2.83. Right, so you find 2.8, the row 2.8 right here, and then we find the column 0.03. Here's the column 0.03 and the row 2.8, where that row and that column meet is 0.9977. Okay, flipping back over here. So I've got the area to the left of 2.83 is 0.9977, but that's the entire area to the left of 2.83. I want the area in between, so I'm going to subtract from that, I'm going to subtract from this the area to the left of 0.94. Right? When I subtract, what I will be left with is the area in between. So now, go back to the chart and find the area to the left of 0.94, which is, find the column labeled 0.9, the row labeled 0.9, column labeled 0.04, and that number is 0.8264. So now I'll come back over here, and I'm going to subtract from this 0.8264. When you subtract those, you should end up with 0.1713. That's the area in between, and that is the probability being asked for. The probability that the sample proportion falls between 0.12 and 0.16. So that is how you would work out a problem like this one. Please feel free to reach out if you have any more questions about this. Thank you.